Recording is in progress, class. Good evening. It is Monday, November 21st. Thanksgiving is on the horizon, but we've got one more assessment, then y'all can relax and whatnot. Today, real simple. We're talking about big O notation. Does anyone know what big O notation is without Googling it? Who's heard of it? I assume some of you heard of it at this point.
Is it kind of measuring the runtime complexity of a code or algorithm?
Yeah, that's exactly what it is. Yeah, my notes here, it's in computer science, that's how we notate performance and complexity of algorithms. Why is this important? Does anyone know?
Resource allocation on your servers, wherever these programs are running.
Okay, that's one thing. What's another good reason to know about your big O?
Oh, it's all about speed, isn't it?
It is about speed. That's right. One last reason you want to know about big O. Can anyone guess?
For when you interview at Google.
Absolutely. You're going to be interviewing and you need to know this because some people are going to say, what's the big O notation on that? Once you've already, solved it in front of them. So you need to kind of know it's a thing. Like a lot of things we do in Code Platoon, we're trying to get you spread out. We're trying to make you, we're trying to get you to the same level as somebody who just spent, 5 years and a lot of money, trying to get this done. So you need to be where you normally would kind of osmose these things and they'd be just normal day-to-day stuff. We need to have you know that they exist and have a working knowledge of them. I can't say I think about big O very often. Most of the stuff I work in is not, time intensive. We're not tight on resources. I don't really care whether it runs in, a half second or in 2 seconds. But some places you go will. The algorithmic traders at our company absolutely care if it's, a quarter of a second or, a thousandth of a second. That's a lot of money. You can do a lot of trades in that time. And you should just, think about it, I guess. Let's open up this slide. Let's look at this together and start from the beginning. Can everyone read that? That kind of looks yucky.
No, I can't not.
Put your sunglasses on. Woo! All right. Turn this back off later. Big O, understanding algorithmic efficiency, benchmarking resources. Here's a nice visualization. I actually neglected to click on these earlier. Can I? Let's go. Let's see. We'll watch this for the first time together. I watched this a while back. Oh, I'm not going to do this in class, but basically, so what this is different methods of sorting, and it's kind of showing you which are the fast ones, which are the slow ones. When it's green, it's done. When it's not green, it's not done. Remember y'all did bubble sort a while back and you thought, man, this is a really great way for searching. It's super not. It's terrible. But this has related to big O, but not exactly what we're going to be talking about. Just want you to know you can do things really efficiently and do things really inefficiently. That's not news to anybody. This is cool. Click on your own time. Performance, read the docs, documentation for benchmarking. Python docs, we're not going to read out of that, but good to take a look at on your own. Let me just make sure this link works. Oopsies. Yeah, good stuff. Good stuff. I'm not going to read for you, nor do I think is great for reading in class. But let's get into the meat and potatoes. What is big O? We talked about it. The complexity of your function, the O in terms of the input size or N. These are 5 of them I've seen, or sorry, these are 6 of them. I've seen 7 commonly referenced. Truly and honestly, there's, I guess, technically an infinite number of them if you want to get more and more and more inefficient. Really, we're going to be focusing on just 3 of these. Getting into the nitty-gritty of it, not going to be majorly useful because we're here at this level, at the level we're working right now, we're pretty much doing things by looping through them twice, or just yes or no. And that's kind of what we're going to talk about here. O of 1 is constant time. No matter what you feed it, no matter how long the list, whether you handed a list of 7 integers or, you know, a Google, is Google a number? Google's a number, right? Isn't a Google a number? If you handed a Google of integers, it's still going to solve it immediately, because let's take a look. What is the, let's look at the first element in an array. You hand an array of any size. That should be list. Don't use the word array in your Python. Return true if array 0 is red, else false. It's going to look at the first one and spit it out. Doesn't care. Doesn't need to know about the rest. That is always going to solve at the same speed. As you can imagine, very difficult to get your algorithm to O of 1 and have it actually do any real useful work. Linear time, O of n. We should be aiming for O of n at the least for most of your stuff. Runtime will grow linearly based on what you pass in. So given an array and a value, for the items in the array, if the item is equal to the value, return true. Otherwise, return false. So as you can imagine, depending on where that value exists in this array, this is going to solve at different times. But keep in mind, O of n, or sorry, big O notation is talking about the absolute worst case scenario. This is assuming the value is the very last, integer, the very last indices, right? Because this could solve in O of 1 if it's the first one, or it could solve in, O of n if it's way down the line. But big O notation is just kind of a guess of hey, worst case scenario, this is going to take this long based off of this much information you're handing it. This is what a lot of you probably do already, and this is fine. The old double for loop, all nested for loop. Every new coder loves their nested for loops. I remember we were doing we were drilling each other in Code Platoon, and I swear to God, everybody who got up on that whiteboard, no matter what it was, I told one of them to reverse a string, and they were like, all right, I'm gonna loop and I'm gonna loop again. Like, man, y'all gotta stop doing that. That can't be your go-to. It could be your go-to if you don't care about speed. But keep in mind, there's generally better ways to get things done. If you're ever for looping and then looping again in the for loop, there's probably a faster way. Now, does it matter? Maybe not. If you're in an interview, yeah, I'd say it matters. I'm gonna throw y'all over here because I have to look at myself when I'm talking, and I don't like looking at the side of the screen. All right, we're good now. So cool. We got an array results for number 1 in array, for number 2 in array, append number 1, number 2, return results. This is going to double the amount of time that it takes for every, I guess, for every what is it? It's better spelled out right here. So this is O and 2, or what do we call this? N of 2 of n. O 2 of n. 10 times the data takes 100 times longer to run through it. And if you don't believe me, I'm going to show you. I will prove it to you. I don't know how you get this. I think this is at least triple nesting. You can have a lot of fun running time analysis on things like that and get a good idea of how, freaking long it takes to keep looping through stuff. But yeah, at worst, do this. If you're in an interview, at least mention, hey, I had to double for loop. I can probably do it better, but this was my proof of concept. Let me refactor that. Key takeaways. This key takeaway probably should come after this stuff that I prepared. Can I open a new one? Don't destroy this. Ah, yeah, wonderful. Over here. I don't want to show you all my work. I'm not going to open it for you. So this is not the greatest example, and if you have a few, complaints as to how I'm setting this up, I get it. There was a lot of better setup I could have done with using like fake data, stuff like that. Don't put it up there, put it up here. Oh, we have to open it first, Jordan. Off to a good start. Code. Example.py. Great. Okay, so here is, a good example, I guess, and not a great example because right off the bat, you're gonna be like, yeah, I would never do that. But some of you kind of are. Well, all of you probably are one way or another, but this is a really extreme example. So, hey, I've got groups and I've got users. I need to do something for each. For all the groups, I need to run through and do some work. For all the users, I need to run through and do some work. I created a list of 30,000 groups and 30,000 users. What I want to do with it, I'm just gonna create a new list. I do something real simple. I'm just gonna append to this list. Actually, I'm not even gonna do that. I don't need to do that. I'm just gonna do. I left some mistakes there. We're just going to literally assign something to output, and we're gonna run it, and we're gonna see how long this takes. That's not as. Oh, I didn't call it. Oh my goodness. My first day of coding. Takes a little bit. We'll see if this is a lot slower than my M1. Interesting. All right, yeah, it's like 30% slower. Cool. Took 12 seconds to run through that. Now, you're going to hear it a lot. People are going to say hash maps, stuff like that. When you hear the word hash or a hash map, that it comes from different languages, and there are some differences between some of the stuff, some of the nuance. But generally, a hash, you want to think dictionary or you want to think object in JavaScript. They're called hashes in Ruby. They're called hashes in Java. But they've got a lot of, we're not going to get too deep into that. But generally, when you hear the word hash, and you're thinking Pythonic, it's really just a dictionary. It's just a key value pair, which means it's got a constant lookup time. You don't have to iterate. It knows what the value is based off of that key. So trying to solve this quick and dirty, it may seem like, just loop through it. That's easy peasy. But we can get it done faster by doing a little bit of pre-work. We could, and I'm making some assumptions here. The assumptions I'm going to make is every single user has a unique group. This is the most inefficient it could possibly be. There could be users, the groups that are shared between multiple users, but I'm just going to say as inefficient as possible. There are 30,000 unique groups and 30,000 unique users, and I need to do something with every one of them. I'm going to do something for every group. I'm going to do something for every user. So spitting out some boring, really bad fake data, really inefficient data, I'm going to create a dictionary. And I'm just going to say, hey, for all of the users, I'm just going to use users. These are identical lists. Can we all agree? This list is basically the same as this, just different names. Create, or rather add to this output dictionary, a user ID, give it this ID, and then a group ID, give it that ID. So user one is going to be user ID 1, group ID 1, user 2, group ID 1, or group ID 2, user group, you know what I'm saying? It's going to create 30,000 users, each with unique stuff, and it returns it. So right off the bat, we're creating a dictionary. Seems like we're doing a little bit of extra work. This one's not creating any extra variables. It's just doing nothing. So you would think it's a little bit more work, but now that we've done that, we can kind of explain why hashes will help us out here, and how we're going to use that is instead of double for looping, or rather instead of nested for looping, we're going to loop twice. A loop and a loop is way less efficient than two loops. Don't need that no more, and we'll keep it. So now, this is basically, I want to show you this to see how we're creating the users, but all this function is going to do is it's going to set a dictionary. That dictionary is going to be equal to the output of this, which we already talked about what it is. Then for the user, in users up here, we're going to loop through this one for all of these. I want you to just do something. Give me some output. And then once you're done with that, once you've looped through all 30,000 of those, for the group and the groups, output is going to be, do something else. Do something for all the group IDs. So instead of looping and then looping within a loop, this is always going to be more efficient. Even at its least efficient, which is what we're doing right now. Because I could be doing something like, hey, for the users where the ID is not equal to this or equal to that, we could be skipping some and saving ourselves some time. This is the least efficient way I could possibly do it, but I'm doing two loops instead of a nested loop. Remember, our time here was what, 12.61 seconds. Now, using a hash, it's 0.04 seconds. And I have to do quite a bit of work over here to even get this to become measurable. It's even adding an extra, digit on these guys, which, oh, did I do that right? Yeah, that's fine. Even doing an extra digit on that, this has only gotten, what is it, 4, 8, 12-ish, 3 times fat or slower. I can add, this actually needs 2. We start doing stuff like this, and then it can actually be like a measurable amount of time. So that was 1.3 seconds. I have no idea how long this will run for, but it's pretty much just going to run forever. Not forever, but it's going to take a while. Some of you math whizzes might be able to take a guess as to how long that's going to take. But I just added, we went from 30,000, 30,000 to, what are we at, 3 million now. For a double for loop, or 2 for loops here, it increased it by, it went from 0.04 to 1.36, totally doable. For a nested for loop, this bad boy's going to run for a while. And we're doing effectively the same thing. We're altering the same amount of data. We're doing the same work. It's just we're having to run through all these and then run back through. We're basically repeating a ton of work. We're repeating a ton of work like 30 million times. Does anyone have any questions about this? I know it's some of this is kind of like no-duh stuff, but it's interesting to really get thinking about. And we'll talk about the takeaways. I'll see if this ever finishes. In fact, no, it's gonna heat my room up. I don't want to do that. I'm not running the M1. I got an Intel in here, so it's gonna get hot in my room if I let it do that.
So just curious, why is Python so much slower than some of the other languages we see?
I should probably be able to answer that.
Not trying to put you in a tough spot here. I'm just actually curious.
Yeah, no, it's the way it's compiled and then read. I believe the word is, I don't want to shoot myself in the foot while I'm recording. I'm going to take a while. I'm pretty sure I'm going to stake my reputation on it. It's because it's being, what's the word? Not interpreted, but I guess it's interpreted. It's being converted, right? It's doing Python and then saying actually convert down to C, and then doing it in C and then reading it back in Python and spitting it back out. But I could be way off on that. That's a quick Google search. But yeah, Python's something like 200 something times slower than Java. And where that matters, it matters, but oftentimes it doesn't matter.
Okay, so it's basically a language on top of a language.
A lot of languages are. A lot of languages are. Let me double check while we're on record. Was I right? Did Jordan know what he was talking about? Python is dynamically typed and an interpreted language, so I was close. basically, yeah, if I'm not wrong, Python sits on top of C++. So you're not just compiling and running it, you're like converting it. You're running it dynamically and then interpreting it. And then, there's a lot that's going on in between. Like, it's not built in its own language. And I think there's a lot of languages like that. I'm pretty sure Ruby is like that as well. I think Ruby's interpreted. But you're always going to see pretty significant slowdowns. Generally, the more a language does for you, the slower it's going to be. Because everything that you're doing that is further away from 00110111100001, that the computer has to make that up, right? Somewhere down the line, the computer is saying, all right, I got to convert to this, I got to convert to this. So if you write in binary, super duper fast. If you need to convert to C, C is still having to tell the computer how to do things, but it's a lot closer to the metal. And every language that gets further away from the metal, every little thing, like Python, you don't tell it, hey, go put this memory location over here. It's like, it just takes a little bit longer. But all of those little inefficiencies that the computer is saying, oh, you don't want to tell me how long the list will be? All right, well, I'll just wait until I figure out how long the list is, and then I'll check the length of it. Then I'll go find somewhere to put it. Remember, it's this big, but I have to remember that this list could change. Whereas in C and other languages, you can say, this is how long my list is going to be. It's never going to change. It's always going to be at least this big. Go put it over there, please. So the computer doesn't have to do any kind of, figuring it out. It's just like, okay, yep, good. So basically, the more complex the language, the more language does for you, the less efficient it's going to be. Python does a ton for you. It's faster to build stuff in Python. Python just doesn't run as fast.
Mm-hmm. Gotcha. Appreciate it.
Yeah. People who know more can give way better answers. I'll never have to think about these things, but I should know better about what Python's doing under the hood. Key takeaways. Searches through hashes are faster than searches through arrays because hashes don't keep track of the indices. Do they not keep track? I guess they don't keep track. They do know what their indices are, but you can look them up without referencing the indices. Wherever possible, avoid nested loops. Yep, showed you that. Way slower. If you're reading through some JSON and you're building a web app and it takes like a second to do it, you're probably fine. But if you're doing some quick things, if you're interviewing for something and they say this list could be 3 to 3 zillion lines long, probably right off the bat say, well, I'm definitely not going to nested loop that then. If you find yourself writing code that has poor big O complexity, consider refactoring. Yep, just said that. Ultimately, know that this exists. Keep in mind the big ones. This one is probably an easy one to remember, but it's just not going to be that common unless you've got functions that are just checking Booleans, basically. This is going to be your looping, and then this is going to be your nested looping. I try to find good examples for some of these others, and I didn't feel like I understood it well enough to explain it, but you can find examples of everything here. If you're real concerned with getting real into the nitty gritty. I've been out of math long enough that when I see log, I just start sweating. I'm like, I don't really know what that means. But I looked it up and now I have a better idea. Anyways. Any quick questions on big O notation while we're here? There are good graphs for this that show you on a chart roughly, actually I had it. It didn't pull down the way I wanted it to. Putting PNGs and GitHub's not preferred. Oh, there it is. That's kind of, mush, but that's pretty squishy. But constant lookup time for the blue one, you can't even see the blue one. O of n, it's going to be a perfectly straight line. And then into the two is going to be the other one. So again, regular loop, nested for loops, bad. I don't know what you have to do to get these bad boys. I'm guessing that's 3 loops or more. If there are no questions, I'm going to stop sharing, and we can talk about the assignments that are pretty straightforward, pretty easy.
So it seems when you didn't do the nested loop anymore and you rewrote your algorithm, but then it seemed to me that was less readable, obviously faster. So is that yeah, it's preferable that to be, to have more speed than have a readable code?
I mean,
Slightly.
that's just like your opinion, right?
Yeah.
We, I don't know. It's whatever you want to do. I would not nested loop anything for simplicity's sake. Another thing you can do, which I didn't even mention, if I do have, lists of a certain length, I can just iterate twice through them. So you could probably, for this, keep in mind, since these are the same and they are in the same spot, I can use the exact same loop and do the same work. I didn't have to loop again. I could run this in the same loop because, well, only because they're the same thing. We established that users and groups are the same. But if you've got the same main iterator, rather than nest, you can maybe hit 2 different things, just break your data up. You could also build out the dictionary in your first loop. I would say it might be more readable to do this. I do agree. It's for grouping groups and the user and users, and that's pretty easy to identify, especially if you start getting into like JSON, where it's like, oh, I got a massive array of dictionaries, but then in that dictionary, I've got a massive array of other, or I'm saying array now, list of other, things that can make a lot of logical sense to want to loop through it, to nest it. But I'd recommend not thinking about it that way. Try to break it apart. Try to, even if it's adding a lot of lines to your code, break it apart. Try to only run 1 loop if you can. It's going to massively increase your efficiency, possibly. It depends on the data size, right? But yeah, to answer your question, I would never sacrifice readability for the sake of putting a double for loop in my code. I feel like there's probably better ways to do it. If not like this, then some other method. You could build each one of these could have some kind of output that you then are working out of, saying, hey, this one, go get all the users, end function, this function, pull from that, look for all these, end function, this one, just keep it moving down the page. If that
Yeah, I only ask in the context of an interview, like if it's more preferable to do it this way.
Yeah, so what I would say is in an interview is if it's a fairly, you'll get some stuff that's not a complicated question, but kind of complicated when someone's trying to decide whether they want to pay you or not. Things get a lot more complex when you're on the other side of a table. I would say it is probably admissible to tell them, hey, I'm pretty sure there's a more efficient way than this, but I'm just trying to get a proof of concept done to make sure that my solution works. So I am going to double for loop it. I would like to come back afterwards and do that. I would never run this for the big data set. So you can do that. And maybe they'll say, oh yeah, double for loop it, I don't care, or whatever. But just make sure that they know that that's not how you would do it. And it's more of I'm just working in my head real fast. That helps me get there quicker. You can do that.
Oh, great. That makes perfect sense. That's great.
Yeah, and always ask these in interviews, always just ask them for anything. Ask them for everything. That'll be a different soapbox some other day, but they ask you to do something, say, oh, do you have an example? Do you have an example output, example input? Can you give me 2 examples of what you'd like to be like? can I look it up? Can I Google it? Can I ask you for questions? What would you do? Ask them everything, and they'll just keep telling you yes or no, and maybe we'll give away more or less than they normally would have. But I've seen more often than not, people shoot themselves in the foot in interviews by making assumptions that I wanted them to do it in a more complicated manner. I've had people just not use libraries before. They're like, oh, well, I know this library exists, but I'm not going to use it. I'm going to do it this way. Or I know that it's maybe better if I build it right here. And I'm always like, no, do what, that's fine. Don't make it harder for yourself. Or, if I want to set a limitation, I'm going to set a limitation. Don't enforce limitations that you think the interviewer wants to see. Just communicate with them while you're working with them. Ultimately, the more questions you ask them, the better it's going to look anyways, because like an interview is basically a coding pairing session. And the more you ask, the more you bring them in, the more they're going to, get a good feel for what you'd be like to work with. And that's really what they're looking for at the end of the day, is whether or not you'd be good to work with. But anyways, that's off topic. All right. Real quick, blast through the problems here, the 2 challenges. Challenge number 1, easy peasy. Read through these, take a guess at what you think the big O is, and then the explanation should be here. Shouldn't take much time at all. No coding required. You're just reading. Number 2. Kind of, up to you to do what you want to do with this, but what this wants you to do is go back through code that you've written and calculate big O for stuff, and then try to fix it. Work as a group to do that. I think this kind of helps explain it a little bit better, but generally, yeah, you're going to be going through stuff you've worked on. Kind of free form assignment here. Nothing real in stone. If you have questions, feel free to ask. I'm going to stop recording now. Probably should have a while ago.